Now you're traveling east at 26.5 meters per second. There's a car approaching you from the west, traveling from the east, traveling west at 23.4 meters per second. Take the speed of sound to be 346 meters per second. If you hear them honk their horn and it makes 1523 hertz noise, what frequency is their horn generating? So this is the full-blown Doppler equation, but we're given the observer's frequency, and we're asked to find the source frequency. Velocity of sound plus or minus the velocity of the observer. We'll sort out the plus and minuses soon. Velocity of sound plus or minus the velocity of the source. Now in this case, we know that for you heading towards the sound, you heading towards the source, we need the plus in the numerator. And for the source heading towards you, we need the minus in the denominator. So we worked out what the signs on the Doppler equation need to be on Doppler's formula. But what we have is we have F observe, and what we want is F source. So we need to multiply through by the inverse of this term, and we get Fs is F observer, right? And it's going to be the inverse. It's going to be the inverse of this bit up here. So Fw minus VW minus Vs divided by VW plus V observed, right? All right, now we have what we're looking for in terms of everything we already know. So let's go up here. The velocity of sound is 346 meters per second. The velocity of the observer is 26.5 meters per second. The velocity of the source is 23.4 meters per second. And the frequency of the observer hears is 1523. Now, before we calculate this, do you think the frequency of the source is lower or higher than the sound we're hearing? Right? It's coming towards you. So what do you think the frequency of the source is? It's the kind of thing to think about when solving physics problems, because sometimes you'll catch a mistake simply because you have an expectation of what the answer should be, or at least what direction it should be going in. Okay, all I've done is form the equation here, and we get the frequency of the source is 1,319 hertz. And that's it for this problem.